it's topic 1.8, valence electrons and ionic compounds of unit 1 in AP chemistry. This is going to be a short one, guys. All right, so the first things we need to know. The likelihood that two elements will form a chemical bond is determined by the interactions between the valence electrons and the nuclei of the elements. Well, we've kind of been covering that along the way, but we haven't put it in these terms. Now, elements in the same column, the technical term for that is a group of the periodic table, tend to form analogous compounds. What's an analogous compound? They're just compounds with similar structures. Okay, they're just similar. So the charges of ions are governed by the number of valence electrons, and they're predicted by their location on the periodic table. If you've taken chemistry with me before, you definitely have covered this. So the group 1 on the periodic table, right, has 1 valence electron, tends to form a +1 charge. Group 2 has 2 valence electrons, forms a +2 charge. We're skipping the middle D period where transition metals are because they have multiple transition states. They tend to form a variety of different ions. All right, so skipping to group 13, which is in our P area of the periodic table. Group 13 has 3 valence electrons, +3 charge, 14, forms a ±4. That was a little tricky, depending on the situation. Group 15 has 5 valence electrons, forms a -3. Group 16, 6 valence, -2 charge. Group 17, 7 valence, -1 charge. Group 18, those are your noble gases, right? So they do not tend to form ions because they do not have a tendency to gain or lose electrons because they are very stable. Right? They have a full outer shell and they are very stable in their neutral state. Okay, so let's look at one example here. So you're given beryllium and fluorine, okay, to compare. And you're told to examine what kind of chemical formula would form between beryllium and fluorine. So beryllium has 2 valence electrons because beryllium is located here on the periodic table, right, in this column. And fluorine has 7 because fluorine is located here on the periodic table. Beryllium tends to form a +2 charge while fluorine forms a -1 charge. I teach the crossing charges method in order to form ionic compounds. And I know this is an ionic compound because I am dealing with a metal and a nonmetal, and I'm crossing the charges. They're both forming ions, right? So I'm crossing charges between them. So if beryllium makes a +2 and fluorine a -1, simply you are going to move the charge to the bottom of the opposite element and remove the positive or negative sign. So that would leave you with Be with an understood 1, F2. So remember that your binary ionic compounds consist of metal and a nonmetal. Okay, second example. You're asked to determine what's the formula of the ionic compound between sodium and sulfur. We're going to do the exact same thing. Sodium makes a +1, sulfur a -2. We're going to cross those charges to the bottom of the opposite element, remove the sign, right? Because once they come together, they form a neutral atom. So we end up with sodium, 2 atoms of sodium and 1 atom of sulfur bonded together. Aluminum and oxygen. We have aluminum with a +3, oxygen with a -2, right? We're going to cross those over to get Al2O3. I do want to show you one example. What if I had Mg and O? Just for reference, Mg is a +2, oxygen's a -2. Okay, when those cross over, you get Mg2O2. However, right, if those values can be simplified, you always want to simplify those, right, as much as possible. So essentially the 2's will cancel. They both can be reduced by a value of 2. So the final answer for this one would simply be MgO. They're both understood ones. That concludes section 1.8.